Okay. So here I told you that instead of array size, I will use the variable which is current array size. Before array size was taken 11, but we have used a variable current array size, and the value of it is array size minus 1. So instead of array size minus 1, I will replace this with the variable current array size, as it is a global variable, so it will take its value what it contains currently. Then this, okay, now okay. Here also, while this code will interchange the root of the heap with the highest index element. So here also, instead of array size minus 1, I am writing here current array size, so that it will be interchanged and these are printed. Now, after swapping printf, after swapping root with the highest element of array size, what the current array size, current array size, okay, and print the array. So after that, what will be done? So now I will create a heap with the reduced array size. That is, if current array size is the 10, then we will again construct a heap with what the array size will be 9. So what I am doing here, I am decrement the size of current array size minus. Then we will call a function which will construct the heap with this reduced array size. Obviously, here's the so this function may be construct heap. struct construct heap, and here we will pass only in this construct heap, but will pass only that means root element has been replaced with the highest index value. So we have moved to the highest level. Now it will be checked with now it will be checked with its child. So the parent is always 1 for this new heap. The parent will be always 1 index. That will be checked with its children. But how long it will be checked? That means until it is within the array size. So what is the array size now? Which I have just done it with new array size. Suppose before it was 10. Now it will be array size will be 9. So current array size minus. So here I have to construct a heap with this reduced array size. Now I will call a function, and here also one key. When the array size is getting changed, that time what will be the value of flag? Flag equals to what? Suppose the last two elements, last has two index elements. They can be that it can be possible that both are children of the same parent, or it can be only the last element is only children of its parent. Based on that, I introduce a variable flag which will be set to either 1 or 0. If we go to this my previous here, I have seen that if left child and right child, these are the same children of same parent, then flag value will be 1. Otherwise, the flag value will be 0. As the array here is all changing, so there also the flag value will be changed. So every time when the array size is getting changed, and we have to construct the heap with this reduced array size, then we have to also find out the value of flag, whether it will be 1 or it will be 0 for that particular array size. That we have to find out. So how to find out? So for that, what I will declare a variable right, and the right will be the current array size. The value would be current array size because it will be the rightmost element in that array. And what will be, and another children will be left, which size will be right minus 1. Now, here, when this current array size will be reduced, so construct heap will be called, and as the size of the array has been changed, so flat value will be changed. So in this function, in construct heap, we have constructed, we have to pass the value of the flag, because depending on flag it will check whether the last two elements are children of the same parent, or only the last element is the only child of its parent. It is determined by getting this value of flag. But how to determine the value of flag? So for that, what I will do here one thing, that right equals to current array size, and left will be, the value of left will be right minus 1, because left and right is can be the two children which will be adjacent to each other. Now it will check if left by 2 and right by 2 is equal, then they are children of the same parent. So I will check here, left by 2 is equals to right by 2. So if this condition satisfies, that means they are both are children of the same parent. So the value of the flag will be 1. Else, that means if left by 2 and right by 2 is not equal, then only the last element is the only child of its parent. So flag value will be 0. So in this way, flag value is determined. Then we construct heap. And passing, because now always the parent is location 1, and root node is at location 1, which has been changed. So we cannot go upper than the root node. So now we have to check the down nodes, whether downward nodes have greater value of this root element. That is, then they will be interchanged. So construct heap will do that interchanging. So construct heap is fault. Now so what I will do, I will write the function for construct. First we declare the function void construct heap, which will construct the heap with reduced array size. And here I have to pass the int parent, which is a case. Now only one thing I had to find out, that construct int flags will be there, and whether I am to see whether 7 is request to pass or not, because the root node is always here, the parent will be the root node for constructed. So I don't have to pass the value of 1, only flag value makes it fast. Let's see what it looks like for constructed flags. If I do this, then now I will define the function void construct and int flag. Actually, so here always the root node is 1, so I will hold here let add it down. Now I will have up down and before that, now if the parent is index 1 element, then its children will be 2 and 3. So its parent will be only children 2 and 3. So with this children index 2 and 3, which is the highest value, that will be swapped to the parent. That is swapped to the root node. So here child next is there. Now it will check if array 2 is greater or equals than array 3, then child next will be 2, else if array 2 is not greater or equals than 3, then next child will be equals to 3. It will be equals to 3. Then we will call this move up down function. So what is the parameter to be passed? Parent value, the child value, child index, which will be swapped with parent, and the value of flag. So move up down, parent value is order is 1, and the child value is child next, and the flag value will be used. That is the construct. So after that, when it has been done, then if parent is, that means root node has the lower value than child next, then that will be interchanged. Again, the new child next, if it has less value than its children, then again that will be interchanged, and it will go up to the size of the reduced array. So void is array size, then parent equals to child, that will be, if child's void is less equals than current array size, then okay, this is the code that we already described how to write in previous class. This move up down will be called. After that move up down, we will get a heap of this data size is with the current data size, which is reduced data size. We will construct it with this remaining elements. So I want to show the after construction of heap, I want to print out the array. That will be again key with reduced data size. So after constructing his after constructing constructing heap with the highest index element array size equals to this, then it will be printed. Then next what are we do? Then again this highest will be interchanged with the root element will be interchanged with the highest index of that reduced array size. So it can go on. So for that, so total these things, which total these things, not this thing, this total code will be written within a for loop. So what can I do? Because every time the root node is just the first iteration, the root node is interchanged, for this example, interchanged with 10th element of that array. Next, from next root element, again here heap is being constructed with the remaining 9 elements. Then again after construction, in root will be interchanged with the index element with the element of index 9. Again we will reduce the array size by 1. So array size will be 8, and again we will construct a heap with this 8 elements, and now the highest of these 8 elements will be placed at the root. So root will be now interchanged with this 8 index element. Then again we will take the next RSS. That is, RSS will be decremented one by one, and it will go on until the RSS reaches to 1. Until the RSS, current RSS becomes, the value of the current RSS becomes 1. Okay, so 4 will be written for that. So I will write it, and we will go to next video for this.